Hey guys, today we're going to be going over everybody's favorite acid-base problems. This problem is actually a continuation of a multiple component problem. I'll leave that link in the description. So just take a minute, read over this problem, pause the video. Alright, so now just quickly going over our symbol. Our goal here is to find the pH after we add our 500 milligrams of calcium carbonate. So then just the diagram shows the calcium carbonate going into the system. Step on over to our analyze section. This system is open because we have mass crossing that boundary. It's dynamic because mass is only flowing in. That means that that mass is going to accumulate, and it's reactive. It's an acid-base problem. So we have one piece of extra data that we need, and that's going to be the molecular weight of the calcium carbonate, and that's pretty much just 100 grams per mole. And then just take a quick look at our givens, listing the problem. Our basis is going to be our 0.5 grams of calcium carbonate. So now taking a look at our calculate section, we have two really important equations. First one is our mass accounting equation. You guys should all be really familiar with this equation. Just mass in minus mass out plus mass generated minus mass consumed equals mass final minus mass original. I think it's really important to use this final minus original part, especially for this acid-base problem. And the other really important equation is our pH equation. So the pH is going to be equal to negative log base 10 of the molarity of the hydrogen ions. So just to remember, molarity is moles of the ion divided by volume, and this is log base 10. So simplify, there's not a lot of simplification that can be done given this is open, dynamic, and reactive. Now let's check out how we solve this one. Go over here to our solve block. Our first step is to calculate the moles of calcium carbonate that are going into the system. Just do that by the mass divided by the molecular weight, and that one will give you 0.005 moles of calcium carbonate. Finally, we need to calculate the moles of hydrogen ions that are in the system originally. You do this by taking the inverse of that pH equation. So it's going to be volume times 10 to the negative initial pH. That'll give you some weird unit, so just put it in moles right here. Alright, so now we're going to take a look at our solve block. These three equations here are our mass conservation equations. This one's for the hydrogen ions, this is for the anions, and this is for the undissociated molecules. So now these two equations are very important. This one says that for every anion generated, 2 hydrogen ions are consumed. That's because the carbonate anion has a -2 charge, so it can accept 2 hydrogens. This equation just basically says that for every one molecule that dissociates, 1 anion will be generated. So now we solve that, and we get this vector here. Now this number is the one we really want. That is the final moles of hydrogen. So we're going to plug that one into our pH equation. We don't have to worry about volume for this pH equation because our volume is equal to 1 liter. So how we extract this number out of that vector is you're going to do x, open bracket, looks like this on your keyboard, and then a 1 value, and it's 1 because MathCAD actually counts this first position here as the 0 position, so this 0.008 number is actually in the 1 position. So our final answer is going to be about 2.1 here. Now we can go ahead and take a look at our MATLAB solution. So there are just a couple quirks I really want you guys to be aware of when you're implementing this into MATLAB. The first of which is that if you want to get log base 10, you have to type out log 10. Just putting in log will get you natural log. That will give you a wrong answer. Also, when you're using sims, it won't actually read any variable that you've named in the previous code. So if you want to name a constant like your original moles of hydrogen ions, then you just have to input an extra equation like I did for equation 6 and equation 7. That should work out for you, and we take a look at our final answer here, and our pH is equal to 2.1, so about the same as our MathCAD. This guy's hopefully feeling a little bit better after all that Jack in the Box. Have a good day, guys.